What are we comparing when we talk about slope? Yeah, but what? So that's really mathy way to explain it. Absolutely right, but that's a really mathy way. What are we like? Let's use simpler terms.
How much the line grows by?
How much the line goes up or grows by?
I think it's triangular.
Yeah, like as it moves another direction. We can't just talk about how much higher it goes. We have to know how much higher, in what span of how far it went, so that it then makes like a triangle, like our slope triangle. So we today are going to work with different situations, all involving slope. And yes, there are planting manuals. When I got my job landscaping, I actually had to go through training. There's a lot to be learned about plants. So a planting manual printed in the grass below shows gardeners could predict the height of trees after their planting. Because, things grow linearly most of the time. And by the way, trees grow only from the top. So that's why if you carve your name in the bottom, it will never move up. And this is a question of mind trap, actually. So trees only grow from the top, and the thing they grow from, or the thing that leads it, is called the central leader. If you cut it off, it's really bad for the tree. Then everything fights for the top, and that's why you see trees with a bunch of just things pointed straight up. It means it was pruned wrong. Sorry, there's your useless input for today.
If you write your name on that part, would it go up?
Yeah, but it's really hard to reach it. It's like the most pointed up branch at the very top of the tree. It's normally the highest thing. That's what tells the tree that it can keep growing. If it hits something and it redirects, then the whole tree follows that, and it redirects. I'm serious. Like trees are smart. Like the limbs communicate to each other. It's weird.
I guess vegans are gonna have to switch to air now.
So that, if you've ever seen those shrubs that are special, like spirals and things, they grow those in boxes. They grow those trained to grow the way they want them to grow. All right, but all of that aside, let's look at some slope. So, oh, by the way, there's a resource page. I hate this schedule. It's got me all screwed up. It's right here. But...
It's got me so screwed up. I keep going wrong path.
All right, so you guys.
Yeah, it's only for Tuesday, Wednesday.
You guys. What is what?
What's it even mean? Yeah. What does what's it mean? Is it like a Greek name?
It's European.
That's not. That's really different.
Yeah, I know. My heritage is pretty lame.
My
My mom's family heritage is German, but. All right. So when we talk about finding slope, the reference points that we use are called lattice points because we are creating. If you've ever done lattice math or things like that, a lattice is things that go two directions, like up and left or down and right or whatever. So a lattice lets us reference horizontal, vertical, right? That's why there are lattice points. Hey, Will, can you sit in the desk like a normal student so you're not blocking your view? Thank you. So, and I forget if this is on your page or not. Yeah, this is 55. So check out the resource page. Try to find the slopes for all of these situations. 1, 2, 3, and 4. Or I.
Wait, what was that?
I. Or I.
Aye, Captain.
Ask computer. It is rise over run. I'll remind you that, but I'm not going to tell you the one. The general slope formula is rise over run. It's not cold outside, but it's kind of like lame. It's like wet, humid. There's a reason I'm not answering questions right now. We can go ahead and ask if you want. Not as long as they come from an intersection. Now, the whole x1, y1, x2, y2 doesn't really matter as long as if I switched and I made this point my x2, y2, I would then have to switch and make this one. It doesn't matter what order you do it in, because if you subtract backwards, it'll all compensate. Because if you end up with a negative over a negative, it just becomes a positive. So the order doesn't actually matter. But remember, as a couple of you asked, and I caved, and I'm going to give it to you, it's delta y over delta x. The y comes on top. Most of the time, mathematics operates kind of alphabetically and things like that, but this is a case where we have y coming before x or above the x. For I, what points did somebody use? Can somebody help me? Tell me what you... Tyler? Might be gone.
0, 1.
Yeah, this intersection point. And 1, 3, that intersects. So that looks like it intersects, but sometimes it's safer to use a point further away to kind of make a larger triangle. So you're fine to use 1, 3, but I'm actually going to use 5, 11. So then my delta y. Yeah, there's a smaller way. You could use this point, you could use this point, you could use this point. Yeah. No, but you can. Yeah, that's fine too. So that would be 4 over 2. Or 6 over 3. Or 8 over 4. Or 10 over 5. Yeah. You are upside down. You need your y on top, your x on bottom. So your slope for I should be 2. The delta y on top. Because it's rise over run. So for a lot of people, it's actually more helpful to make your triangle on top of the line. So if we look here, if you want to think about your rise first compared to your run, I think this intersects right there probably. What's your rise? I chose a point further than it needed to be, but I just find an easy intersection. So making the triangle on top, then you'd go up first and then over, which would find your 6 first and then your 4, which would give you the correct order. 6 over 4 or 3 over 2, which of course you could have made a smaller triangle, but the graphs appear kind of small, so I don't want to write too small. Well, a few different ways that we can do this, but I looked at my points to begin with, and I said from 1 to 11 is a change of 10, and then from 0 to 5 is a change of 5. And the y change has to be on top, the x change on bottom.
That makes more sense. Okay.
Is everyone okay with 1 and 2?
Yes.
And I'm gonna cut this out and put on my journal.
You can if you want. I don't really care. I'm not collecting your math rooms again.
Wait, seriously?
I'm probably going to collect random homeworks here tomorrow, but yeah, so make sure your homeworks are done because I'm collecting random ones now. I did math 7 last week. So you still always have 2 days. Always you have 2 days of business.
So it's either Monday or Tuesday somewhere?
Or anything previous to that, like what we did before the test.
Which test?
I did one problem.
Like anything else. All right, in 3. You still got it?
No. But I.
You what? No. Oh, you forgot? Think
Oh,
about it.
right. Okay. Will we have a test before the end of the year?
Yeah, we're gonna have a final.
Oh, right.
Like you have really big ones at the oldest.
But that's probably the last test of it. Like, I don't think we'll have another chapter test. I'm probably just gonna roll it all
Are
out.
you serious?
Maybe, but that'd be like.
Can you make it like super easy?
Can.
But will
Will
No.
you? May.
What's my delta y there?
Two.
6, isn't it?
Oh, wow.
And 9.
Yeah.
So 2/3. Nope. Bribery is wrong. So guys, when I do this, a lot of times I pick points wider apart than they need to be, but that's easier for your brain than putting them really tight together, making a tiny triangle. At least for me, it's easier for my brain. So now I can think, I go from 4 up to 10, so that's a 6. I go from 0 over to 9. Wait a minute. Those lines aren't the same. What are they, Blol? Not congruent. Or sorry, not true. Parallel, right? If the slopes are the same, which they are here. So these. Aha.
One sheet and one didn't.
So this is you planted the seed in 3. 4 is you planted the plant already growing. Right? It already had a height when you planted it.
Oh, you gotta have height, right?
No. Not if the seed's in the ground. The seed's height would actually be negative, really, if we talk about height referencing from ground level. I don't know that will work very well, but you can try. My garden, I start my seeds in pods, and then I take the pods outside. I garden. Do you find it hard to believe that I have a garden? What do you guys think I grow? Tomatoes.
Avocados.
No. Peppers. You guys know I like spicy food. Summers take like years to get back. Any of your parents have gardens? Spaghetti squash is really good. Well, yeah, but spaghetti. What I grow. We can. So, hey guys. Hey. I'm going to skip through things quickly and see if we can't spend some time on homework during class, but I need your attention for a couple minutes. If we look at triangle A, slope triangle B, or slope triangle C, are we going to get different results?
No.
Why?
Because there's lines.
Ooh, who can do raise this hand?
Okay, because they're the same line, they'll have the same slope, but it will just be like a larger triangle, but still same slope. It'll still be
So, Izzy, you got a way to rephrase that? Use mathy words? All of those triangles would create... equivalent fractions, right? So those ratios be equivalent fractions, right? What?
Wait,
Yeah.
the slope is a scale factor.
No. No, be real careful trying to make... The slope would be... No, if we're trying to say, like, slope comparing things in the triangle, the slope is the relationship of the vertical leg to the horizontal leg. So we could maybe make an argument there, but... So Thomas and Ryan are both going to open bank accounts. And we talked a little bit about simple interest, right? You earn the same amount every time. So compare rates of earning. And is this on your resource page?
No, it's not. No, we have 756 and 3 books. I mean, it is on the book that we totally have in front of us.
Yeah, that you should.
I have it. It's right here. I'll ask her. No, you can hook me up.
So, since you don't have it in front of you,
I do.
if I try to make, hold up, if I try to make some straight lines, is it angled?
Just a little bit. Yeah, just a little bit. It goes
No, that's it. That's right.
Now it's right. It was a bit.
Yeah, it was still kind of.
I'm perfecting this though, so just like
So now if we look at some grid lines, or hi.
Yeah, the one is really off.
What do you mean?
For the first one, it's off one. Like off one.
Oh, yeah.
I think that's the intersection though.
But that's where it seems to
So
intersect.
should you have two then? One for the
then
one
choose
and
a different color for that spot. And then you can have the intersection and you can have one.
Or we could try to approximate that's like 1 1/4, maybe. Or something.
I just said whatever. Well, we like. So Ryan's is 2, I think. Wait, no, it's half. I think. Yeah, it's half.
I know. I gotta shift. What lattice point can we use for Ryan? Annie? The 4-2. Right? This point right here lines up with some intersections. Now, Thomas is a bit more complicated, it seems like. 2's off slightly.
But the one that showed the intersection. Thomas is neat. It's like the intersection now. It's like 1.5.
Yeah, right. That's slightly over 1.
Let's just do 1.5.
So for Ryan, we've got the y change of 2 and the x change of 4. Right? So essentially 1/2. And for Thomas, got a y change of like 1 1/4 to 2.
Wait.
Yeah, it's slightly beyond the 3. So if I try to like approximate here,
Maybe like 0.5, right?
Yeah.
I feel like it's a little point higher than 0.5. Because your arrow's going down.
yeah, sorry, it just didn't come out straight.
That's just
If this was a half, this would perfectly be at 1, which it's not. It's at 1 1/4, which is also why sometimes we choose lattice points further out. This point would be at 2 for the y, but slightly beyond 3. So we can use a bunch of different stuff. We could try 2 and 3 point. No, not 0.8.
That's like 0.5.
3.2. Sure, so it'd be like 1 over 1.6 or something like that.
Something like that.
Now, be careful. We're comparing fractions. Whose account is growing more quickly?
Yeah, it's Ryan. Yeah.
Wait, it's
That's a
Yeah.
half, and that is only. That one's over a half. Isn't it? Is it that one over a half?
Well, if we say 2 and 3.2, then 1 and 1.6. So, which, yeah, he had an appointment. Calm down. So, we're in the know. Us teachers know a lot more than you guys think. Think about which value is larger. Would $50 a week, which is what this is, it's y compared to x, right? Per y per x is what your slope is. So if I reduce it down to unit rates, I got a half per week. Whereas this is about 2/3. How much money would you rather have? $50 or 2/3 of a dollar? 2/3 of a dollar. Right. Well, and 1 divided by 1.6 is not exactly. It's 0.625. So it's about 63 cents.
Literally seemed going faster. Wait, was Thomas or Ryan faster?
Thomas, dude on the left. Because so this fraction, when we make it a decimal, is like 63 cents compared to 50 cents.
I don't get it. Why does the graph look like that then?
So the graphs are kind of annoying us, right? Sometimes the graphs are poopy. Let's use the tables. So grab something to write on and with. Grab something to write on and with.
So let me ask you a question.
Okay. Shouldn't I lay down on the couch first?
Whoa. Hey,
If you've ever been to like a therapist, right? You normally lay on the couch. It depends on where you go. I lay there. You guys can just sit on the couch and then put my feet on your coffee table. So.
You go to a therapist?
How from the table? It is good to talk to people. How from the table can we find the delta y and the delta x? Alex?
Well, we would take like the interest earned, and well, we would take 2 points from the interest earned and put that on top of a fraction.
So maybe I'll take my first and my last, just because, sure.
And time in weeks we put on the bottom. And since it's delta y and delta x, like the larger value would have to be on the left, and the smaller value would be on the right.
I have no idea.
Okay, well, let's compute this. So this would be what? $5.40. And this is. So then the division becomes $5.40 divided by 9. What's 54 divided by 9? His slope's actually 60 cents. Or 0.6.
Wait, but his slope is his first thing?
His slope is actually his unit rate. That's how much he makes per week. This is what? How much?
5 and then 10. 10.
We were right with whose is higher. We were just slightly off with our approximation because we were like guessing where the value is. So the table is sometimes much more useful as long as you can identify, okay, this is X, this is Y, this is X, and this is Y. And we look at them separately. Questions. Finding slope from a table will probably be on your final. Slope is important stuff that you should know. Alana?
I did it a different way, but I didn't really get how you get the math.
So we're looking at what's the change in Y and the change in X. I chose my first and last points just because it doesn't really matter. We could have chosen different points and done like here, the change in Y is $1.80. And then here, this is 3. So I could do 1.80 over 3, and that still will get me that slope. only works here because the 0, 0 point actually exists. So please don't think that always works. That only works with proportional relationships. Well, the slope is always your unit rate, and your unit rate is your slope. But be careful, because that doesn't necessarily mean that the equation is nice and simple. So if you start with a certain amount of money already there, or like if there's a y-intercept, then your equation gets more complicated. And then the table method, we have to do the change. So what Alana's saying is we could have actually just set up this value. Ooh, I forgot I was using red last time. So Alana said, if I take 240 and put it over 4 and reduce it down, it becomes 0.6 over 1, which is your slope. That totally works here. Because there are also a 0 point here and a 0 point there. So essentially, Alana, what you did was you went from 0 to this value and 0 to that value, and you got your delta y was 240 and your delta x was 4. That makes sense?
Good afternoon. My apologies for the late announcement here. There will be no Cardinals softball practice today. No Cardinals softball practice. Thank you. Riley Video, please come to the office. Thank you.
That's what I'm going to tonight. We don't have any card softball, actually. We have Nina's our only softball player.
You're in the 8th grade? She's pretty scary.
Maybe, but I was planning on going to the invitation on the 5th. They talked to me next week, I might be able to go. If anybody would like to go support Mina with me, I'm planning to go watch her tomorrow. Give me dates and it works out. I like supporting you guys. Alright, now I like this problem because my father-in-law's name is Cliff. Yeah.
Will there be a calculator allowed on the Cliff?
Oh, yes. Yeah, my name is Clifford. He had the name before the big red dog, Annie.
Are we allowed to take the final 2 days before the class actually ends and then just play Minecraft?
Yeah, but actually we're taking the final next week. So.
Wait, you play Minecraft for
Okay, so then there will still be other class days where we just kind of either do fun project stuff or short Like one thing we do is a bicycle lab where I bring in 3 different bicycles and we do some calculations about them and stuff. Another thing which I doubt we'll have time for, but I've done in the past, is doing an egg drop project.
Oh my god, let's do it!
I mean, you could grab one. Go to Desmos and go look at their creative art. So, I've lost a lot of you. I got 10 minutes left. Hey, let's not do that. Speaking of which, I need CC3 books back as we get towards the end of the year. So if you have borrowed a CC3 book and have it in your locker or at home or anywhere else, I need it back. Just by the end of the year. The green ones, the CC3. So, what we want to talk about here is how we can visualize steepness. So, we want to be able to do this mentally, but be able to make little sketches of it. If I made you a triangle that has the same length here as it does here, what would this slope be? 1, right? Just 1, right? Because it'd be 4 over 4, it'd be 1. So this, a standard, and you might want to write this down because it's beneficial to know, a standard 45-degree angle, which is half of a 90. Part of this is on your homework, by the way, guys, for estimating what the angle measure is based off a 90-degree comparison. A slope of 1 is 45 degrees. So if the slope is higher than 1, where will it be compared to this? Above it, right? Steeper. Higher than 1. If it's lower than 1, It'll be lower than it.
That question was asked.
So try to sketch little triangles to visualize all these guys' slopes. So will it be taller than it is long, or will it be long? Like, how will it look? So I'll help you with the first one. A 7/5 slope, or 7/5. It's greater than 1, right? So we'd have a rise of 7, a run of 5. My run will be shorter than my rise.
They're the same.
What?
I know. Keep it. Do breeze. Do breeze.
Okay. Oh, can I just do this?
Debris.
Couldn't you just follow the
Wait, you just did breeze.
you could just follow the slant and
What?
stuff.
Oh, like boobies.
No, he just cursing. Breeze and stuff.
Lucy versus Bree, same triangle, but rotated differently. Yeah, I mean, it depends on how you think about it. I don't want to go too deep into the geometric right now. So, Alana, what were you noticing?
So, Lucy's and Cliff's, they do the same thing.
Cliff's triangle, 10 and 14 is going to come down and be the same slope line. Right, so Cliff's, I'm coming. Cliff's 10/14 compared to the 7/5, same thing.
Wait, so what wouldn't Breeze be the same if you like turned it and flipped it?
If we turned it, flipped it, yes. But if we're just talking about slope comparison, this is less than 1, which means this angle here will be less than 45. So maybe 35, maybe 40, somewhere around there. This being more than 1, this is bigger than 45, maybe 50, 55, somewhere around there. And actually, here in Math 1 and Math 2, the next classes that you guys will take, you'll learn how to very easily calculate that exact angle measure. And it seriously takes, this long. I'm hitting 1 button. I'm hitting 2, 3, 4 buttons, and then a parentheses. Oh, that angle measures 54.462 degrees.
You got 50 to 55. You got it.
What button you hit?
He did get it.
What did you do?
Inside the range.
This is called trigonometry.
Oh.
So, hey, calm down. Trig's actually really easy. All because it has 4 syllables.
That's what my mother said, but I still don't want to learn.
Actually, it's got like 5, right? Well, yeah, you're just afraid of it because it's a big word. What do we do? Count? I don't count. So, hey, really quickly, just to drop some knowledge and hopefully seed some interest. Trigonometry is often known by its little expression. Now, I'm going to explain to you what I just did, and maybe blow your mind, maybe you don't care. These represent opposite, hypotenuse, adjacent. The big letters represent trigonometry functions, which are buttons on your calculator. The sine, S-I-N, looks like sin. Cos is actually cosine, and tan is actually tangent. What this means, I'm going to pull out one formula, show you how it works. This, and this is just like a mnemonic device to remember things. This means the tangent, and that's a function, of an angle measure will equal a specific ratio of its opposite side compared to its adjacent side, because trig understands slope. So what I did, what I did was I set up the tangent of my unknown angle, right? We'll call this x, equals 7/5. How do we undo an operation? Ooh, but instead of opposite in math, what word do we use? Starts with an I.
Oh, inverse.
Inverse. So, hey, give me your eyes just for a second, because this is how easy this actually is. The inverse of the tangent function on your calculator is just second tangent. It's the inverse function, really easy to get to. So you would hit inverse tangent over here, which is actually tan to the power of -1, which means x will equal, because the same thing has to happen here with the inverse tangent. All I typed into the calculator, inverse tangent button, 7/5, and that will immediately spit out.
You know
your
on the
degree
Desmos calculator, so if you put enter, it makes a new like shift thing. If you put like say x equals 7 and then put the shift and then make the equation with x, it'll put it as 7.
Now the one thing is your calculator has to be set in the right mode. So it has to be in degree mode. If you hit mode and you go look in there, there's degrees, and then there's other selections you would want to be in degree mode.
Choose degree mode.
Because sometimes we work in radians, which are another way that we can talk about how big an angle O is, but it's different in degrees. Yeah. The math print versus the classic one. Yeah. Did it work out though? Did